Okay, Wildcats, there we're at Journal page 60, exponential growth functions. Example 1, select the domain and range of the given function. Then identify the new values of the reference points and the asymptote. Use the values to select the correct graph of the function. So g of x equals 2 times 4 to the x plus 3 minus 5. The domain of the function is a set of all input values for which the function is defined. The range of a function is a set of output values of the function. Step 1. State the domain and range of g of x. The domain of g of x is x such that negative infinity is less than x less than infinity. The range of g of x is y such that y is greater than negative 5. Step 2. What are the values of a, h, and k? So a is this value right here, 2. H is minus 3. And k is negative 5. Okay? Now, step 3. The asymptote y equals k will become y equals that number right there, negative 5. So y equals negative 5 is your asymptote. Okay? All right, step 4. Graph g of x equals 2 times 4 to the x plus 3 minus 5. Now, before we do that, we're going to graph our asymptote y equals negative 5. Okay? Okay? Now, we're going to use our calculator to find the points to graph. So, we're going to come over here, go on, new document, no, add graph. I'm going to do 2 times 4 to the x plus 3 minus 5. Okay? We're going to press Control T, and we're going to look for points that we can use. Now, really probably don't want to use decimals, so we're going to start with the point negative 3, negative 3. And negative 2, 3. Okay? All right? So we have those points graphed. Now, we know that graph falls along the asymptote and then goes through the points. Okay? All right, go ahead and finish up the graph. All right, let's take a look at the next example. All right, example 2. Select the domain or range of the given function, then identify the new values of the reference points in the asymptote. Use the values to select the correct graph of the function. So you have g of x equals negative 0.5 times 6 to the x minus 4 plus 5. The domain of the function is a set of all input values for which the function is defined. The range of a function is a set of output values of the function. Step 1. State the domain or range of g of x. The domain of g of x is x such that negative infinity is less than x less than infinity. The range of g of x is y such that y is less than 5. All right, so what are the a, h, and k values? So a is right here, negative 0.5. H is 4. And k is 5. Okay, the asymptote y equals is this value right here, 5. So the asymptote y equals 5. All right. All right, let's take a look at the next step. Step 4. Graph g of x equals negative 0.5 times 6 to the x minus 4 plus 5. So the first thing we're going to do is graph the horizontal asymptote y equals 5. So let's do that now. Okay, now let's graph this on our calculator. So on new document, no, add graph. So negative 0.5 times 6 to the x minus 4 plus 5. Okay, so we're going to press Control T. We're going to go through and look through the table. So probably 5.2 is a good point. Okay, 6, negative 13. Okay, and that should be enough points that we can use. All right, now what I did was, since we really only had one good point here, I wouldn't added negative 10, negative 11, negative 12, negative 13 to our table so we could have the point 6, negative 13. Okay, now you can see that the graph follows along the asymptote and curves down and goes to that point. Okay. All right. Go and finish up graphing example 2. All right, example 3. A certain stock opens with a price of $5.40. Over the first 3 days, the value of the stock increases on average by 50% per day. If this trend continues, how many days will it take for the stock to be worth $65? Enter the function that corresponds to the given situation. Select the graph that correctly shows the function and use it to make a prediction. Round your final answer to 2 decimal places. An exponential growth function has a form of f of t equals a parentheses 1 plus r to the t, where a is greater than 0 and r is a constant percent increase for each unit increase in time t. The base 1 plus r of an exponential growth function is called the growth factor, and constant percent increase r. In decimal form, is called the growth rate. Step 1. Complete the function g of t equals a parentheses 1 plus r to the t. Okay, so let's go back to the paragraph. Now, a certain stock opens with a price of $5.40. So that's your initial value. That's your A value. So that's 5.40 parentheses 1 plus we need to find the rate, which is 50%. So that would be 0.5 to the T. Now you can go and add those, okay? And we'll get to that on the next page. Okay. So when you add the 1 and the 0.5, you get 1.5. So there is your equation. And we're going to graph that. Okay. Now, technically, this is plus 0. So our 0 is our asymptote. Okay. So we're going to have an asymptote here at 0. Okay. Now, we want to know when the stock will be $65. So we're going to put a horizontal line at 65. Okay. And let's go ahead and graph this. Now, normally I would say use your calculator, but honestly, I would come to, when you want to find a point of intersection, Desmos is probably better than the calculator. So let's go ahead and do that. Okay, so we're going to go to Math Tools, Graphing Calculator. I don't know what that is. Try to get that out of the way. All right, and so then I'm going to graph 5.4 parentheses 1.5 to, you have to use x, you can't use t, okay? And then we're going to graph y equals 65, okay? And then we're going to come over here, we're going to zoom out till we find the point of intersection, and that is right there. And so there's the value we want. So that's 6.1 days that it'll take to get $65, okay? So based on the graph above, in how many days will the stock be worth $65? The stock will be worth $65 in 6.1 days, okay? So if you wanted to sketch a graph, you know that about right here is where they intersect. So you know the curve would fall along here till there where it intersects, okay? All right, go ahead and finish up the graph and example, and have a wonderful Wildcat day. Oh, wait, hold on. It says 2 decimal places. Almost made a mistake. So you want 6.13. Now you can finish your examples and have a wonderful Wildcat day.